Have you ever wondered if we're alone in the universe? What if life exists beyond Earth, specifically on Europa, Jupiter's moon? The universe is a vast expanse of cosmic wonder, filled with countless galaxies, stars, and planets. Among the cosmic bodies that orbit our sun, Europa, one of Jupiter's icy moons, holds a special intrigue. This celestial body, smaller than our own moon, is believed to harbor a subsurface ocean twice the volume of all of Earth's water combined. But what makes Europa even more intriguing is the possibility that this distant, icy moon could harbor life. Europa's potential for life has captivated scientists for decades, sparking a myriad of questions. Could life exist in its subsurface ocean? What would it look like? How would it survive in such extreme conditions? To find answers to these questions and more, NASA is launching an ambitious mission to Jupiter's intriguing moon. The Europa Clipper mission, an audacious endeavor set to launch in the next few years, aims to investigate Europa's potential habitability, scrutinizing its icy shell and subsurface ocean. The mission's primary goals are twofold: to determine Europa's potential for life and to characterize its subsurface ocean. To achieve these goals, the spacecraft will be equipped with a suite of scientific instruments designed to measure and analyze a wide range of data. These instruments will be used to study the thickness and properties of Europa's icy shell, the depth and salinity of its subsurface ocean, and the composition of its surface and atmosphere, among other things. The Europa Clipper will be a pioneering mission, pushing the boundaries of our understanding and potentially reshaping our perceptions of life in the universe. But as with all great endeavors, the mission is not without its challenges. From the intricate design of the spacecraft to navigating the harsh conditions of Jupiter's magnetic field, the Europa Clipper mission is a testament to human ingenuity and the relentless pursuit of knowledge. Stay with us as we delve into the fascinating mission to Europa. So what exactly is the Europa Clipper mission? The Europa Clipper is a bold venture by NASA set to dive into the enigmatic icy world of Jupiter's moon, Europa. Its primary goals are twofold. First, to determine Europa's potential for life. Second, to characterize its subsurface ocean. This mission is not a simple one. It's a daring exploration that seeks to unravel the mysteries of an alien world, potentially harboring life beneath its icy exterior. The spacecraft is a marvel of engineering. It is equipped with cutting-edge scientific instruments, a powerful propulsion system, and a robust power generation mechanism. Each component is designed with precision and purpose, prepared to endure the harshness of outer space and the intense radiation environment around Jupiter. The mission timeline is as thrilling as the mission itself. It begins with the launch of the spacecraft from Earth. After a journey of several years, the spacecraft will insert itself into orbit around Jupiter. From there, the Europa Clipper will execute a series of daring close flybys of Europa. These flybys, each bringing the spacecraft within just a few hundred kilometers of the moon's surface, will provide us with unparalleled views and data of Europa's icy shell and what lies beneath. The spacecraft will carry out its mission over multiple orbits around Jupiter, each time swooping down close to Europa to capture detailed data. These flybys will allow us to map the moon's surface, probe its interior, and search for signs of geologic activity. This mission is not just about exploration, it's also about innovation. The Europa Clipper will carry 9 scientific instruments, each designed to study a specific aspect of Europa. From analyzing the composition of its thin atmosphere and surface to probing the thickness of its icy shell and the depth of its subsurface ocean, these instruments will work together to paint a comprehensive picture of this intriguing moon. The Europa Clipper mission is a journey of discovery, a chance to broaden our understanding of the universe and our place in it. It's a testament to our collective curiosity and our insatiable desire to explore the unknown. With this mission, we are stepping into the unknown, ready to unlock Europa's secrets. What tools are we using to unravel the mysteries of Europa? Let's dive into the scientific instruments aboard the Europa Clipper that will help us explore this intriguing moon of Jupiter. Each instrument is designed with a specific purpose, and together they form a comprehensive toolset for understanding Europa. First up, we have the MASPEX, or the mass spectrometer for planetary exploration. This device is quite like a detective in its function. It will measure the composition of neutral and ionized species in Europa's atmosphere and any detected plume. It will analyze the chemical makeup of gases and dust to identify major and minor constituents. This includes molecules indicative of water, salts, organics, and potential biosignatures. The MASPEX will provide us with compositional maps of Europa's surface and atmosphere and insights into plume composition if present. Next on the roster is REASON, the radar for Europa assessment, and sounder, ocean to near surface. This dual-frequency ice-penetrating radar system operates at 9 Hz and 400 MHz. It's designed to measure the thickness and properties of Europa's icy shell and underlying ocean. REASON will detect and characterize subsurface layers, determining ice thickness, salinity, and potential liquid water pockets within the ocean. The data from REASON will provide three-dimensional maps of Europa's ice shell and ocean depth, giving us a deeper understanding of its internal structure and potential hydrothermal activity. Then we have MISE, the Europa Ultraviolet Spectrometer for Ice Composition Experiment. This instrument measures reflected and emitted light from Europa's surface. It's a bit like a geologist, analyzing the surface composition by identifying minerals, salts, and potential organic materials. It will also detect surface composition changes across Europa's diverse terrains. The data from MISE will offer us maps of surface composition and distribution of key materials, giving us insights into geological processes and the potential for past or present habitability. The spacecraft also carries a host of other instruments, including the Surface Dust Analyzer, Europa Thermal Emission Imaging System, Europa Ultraviolet Spectrograph, Bipolar Electrostatic Sounding Technique, and a couple of magnetometers for good measure. Each of these instruments has a specific role, and together they form a comprehensive scientific package. Data acquisition, processing, and analysis are a critical part of the mission. Each instrument will collect data in its unique way. Then through complex algorithms and human interpretation, this raw data will be processed and analyzed. This process will help us understand the data in the context of Europa's environment and our existing scientific knowledge. The type of data these instruments will deliver is diverse and rich. From compositional maps of Europa's surface and atmosphere to three-dimensional maps of its ice shell and ocean depth, the data will provide a multifaceted understanding of this icy moon. Each piece of information will contribute to our understanding of Europa, its potential for life, and its geological history. These instruments are our eyes and ears ready to reveal what Europa has to offer. The journey to Europa is not without challenges. How are we overcoming them? Let's dive in. Firstly, when designing and developing the spacecraft, it's crucial to consider the harsh conditions it'll face. Jupiter's intense radiation belts pose a significant threat. To protect the spacecraft's sensitive electronics, a radiation vault made of high zirconium alloy is used. This vault, while not completely eliminating radiation exposure, dramatically reduces it to manageable levels. The spacecraft also has to withstand extreme temperatures. The frigid cold of space, the intense heat of the sun during the early stages of the mission, and the thermal radiation from Jupiter once in orbit. To deal with these fluctuations, the spacecraft uses a combination of heaters, radiators, multi-layer insulation, and a high emissivity white paint that reflects solar heat. Now let's talk about navigating this spacecraft. Achieving close flybys of Europa while maintaining a stable orbit around Jupiter requires intricate maneuvers. The spacecraft will use a gravity assist technique, leveraging the gravitational pull of Jupiter's other moons to adjust its trajectory. This technique, also known as gravity slingshot, allows the spacecraft to change direction and speed without using much fuel. The navigation system also includes star trackers and gyroscopes. The star trackers constantly take images of the stars and use their positions to determine the spacecraft's orientation in space. The gyroscopes, on the other hand, measure changes in the spacecraft's orientation. Together, these instruments provide accurate navigation data, ensuring the spacecraft stays on the right course. And what about communication? How will the spacecraft send all the collected scientific data back to Earth? Well, The Europa Clipper is equipped with a high-gain antenna that can transmit large amounts of data over vast interplanetary distances. The spacecraft will primarily communicate with NASA's Deep Space Network, a global system of antennas that support interplanetary missions. However, transmitting data from Jupiter to Earth isn't as simple as hitting the send button. The data has to be carefully packaged into a format that can survive the long journey through space. Once the data packets reach Earth, they need to be decoded and converted back into usable information. This process is handled by sophisticated software algorithms designed to ensure data integrity. The communication system also has a low-gain antenna for receiving commands from Earth and a medium-gain antenna for faster data transmission when the spacecraft is closer to Earth. These multiple communication channels provide redundancy, ensuring continuous communication with the spacecraft. With cutting-edge technology and innovative solutions, we are ready to face the challenges that lie ahead. The journey to Europa is indeed a formidable one, but with these technical details in place, we're well equipped to tackle it head-on. The Europa Clipper mission stands as a testament to human ingenuity and our relentless quest for knowledge. What could this mission mean for the future of space exploration and our understanding of life beyond Earth? This is the question that hovers in the minds of many as we delve into the future implications of the Europa Clipper mission. Astrobiology, the study of life's origins, evolution, and distribution in the universe, stands at the brink of a transformation. Unraveling the mysteries of Europa, a world that has long tantalized scientists with its potential for life, could lead to significant leaps in this field. By analyzing the data returned from the Clipper's scientific instruments, we could deepen our understanding of the conditions necessary for life to exist beyond our home planet. Identifying signs of life or conditions favorable to life on Europa would not only revolutionize astrobiology, but also redefine our perception of where life can exist. It would show that life is not limited to the temperate surface conditions we have on Earth, but could also thrive in the icy moons of gas giants, beneath sheets of ice, and in oceans warmed by tidal forces. The Europa Clipper mission is also a stepping stone to future explorations. The data collected will be invaluable in planning subsequent missions, not just to Europa, but to other icy moons across the solar system. The mission could inform the design and instrumentation of future spacecraft, shaping how we approach the search for life on other worlds. Moreover, the Clipper mission could serve as a precursor to a potential future lander mission. By mapping the moon's surface and subsurface in high detail, it will identify potential landing sites and hazards, paving the way for the next generation of explorers that might one day touch down on Europa's icy surface. But perhaps one of the most exciting implications lies in the potential for widespread scientific community engagement. The Europa Clipper mission is not just a venture of a single space agency or a group of scientists. It is a global endeavor, and its findings will be shared with the worldwide scientific community. The data returned will be a treasure trove for researchers. Scientists from various disciplines, from geologists studying the icy shell and subsurface ocean, chemists analyzing the composition of the plume and surface, to astrobiologists searching for signs of life, will all have a wealth of information at their disposal. This cross-disciplinary engagement could lead to groundbreaking discoveries and fuel scientific advancement. In essence, the Europa Clipper mission is not just about a single journey to an icy moon. It's about propelling our understanding of the cosmos, inspiring future explorations, fostering global scientific collaboration, and perhaps most tantalizingly, inching us closer to answering the age-old question, are we alone in the universe? The Europa Clipper mission could revolutionize our understanding of Europa, opening new frontiers in our quest for life beyond Earth. As we embark on this exciting journey, let's reflect on what we've learned. Our journey began with an understanding of the Europa Clipper mission, a monumental endeavor to explore Jupiter's icy moon, Europa. This mission's primary goal? To determine if Europa has the potential to support life and to characterize its subsurface ocean. Our spacecraft, designed with state-of-the-art equipment, is equipped to face the harsh environment of space with its extreme temperatures and radiation. It has been engineered with precision to navigate the intricate maneuvers required to achieve close flybys of Europa while maintaining a stable orbit around Jupiter. We then delved into the treasure trove of scientific instruments on board the spacecraft. The MASPEX, Reason, MISE, and others, each with their unique functionalities, will collect and analyze data to achieve our scientific goals. The data collected will not just fill our repositories, but revolutionize our understanding of Europa. It will provide compositional maps, identify major and minor constituents, including molecules indicative of water, salts, organics, and potential biosignatures. The mission's engineering challenges, the innovative solutions implemented, and the scientific instruments on board are all pieces of a larger puzzle. These elements combined are our gateway to understanding the potential for life beyond our home planet. But it's not just about the data we acquire, it's about the impact this mission will have on astrobiology, the connections it will forge with future missions, and the engagement it will foster within the scientific community. As we venture into the unknown, remember, we are not just exploring Europa, we are exploring the possibilities of life beyond Earth.